Hey everyone, welcome back to the third tutorial of the xHCI driver development series. In the previous parts, we've successfully mapped and reset the controller, so the next logical step would be to configure and start it. But before we can do that though, we need to create and configure a few data structures first, which these next couple videos will be focused on. In this video specifically, we'll focus on the device context base address array, or what you may remember from the operational registers as DCBAA. When I was first learning about xHCI and came across this device context array structure, I was honestly pretty terrified of the long name, and it took me a while to understand all the details of what the documentation and the spec talked about in regards to it. But after coding it up and actually using it, it's honestly not that bad. So my main goal in this video is to get rid of any of your fears or confusions in regards to this data structure. Before I jump into the diagrams though, let's go back to the code and do a couple of setup steps first to prepare the context for what we're doing. Let's get started. So in the last episode, we've ended right here, with resetting the controller. The next step that we would need to do is to start configuring the operational registers to prepare us for eventually starting the controller again. The setup routine is fairly straightforward and is very well documented in the spec. It's pretty much the same across all implementations as well. The first thing you usually need to do is set up the device notification control register and set it to a value that allows any event or notification to come in. The upper 16 bits are reserved, so we just have to set the lower half to all ones, or in hex 0xFFFF. The next step is to set up the USB config field to be the 32-bit value of max device slots that we retrieved from the capability registers. Again, just a boilerplate setup procedure that we have to go through. After that, we would need to do two big things. First, set up the device context base address array, and second, the command ring. Since each of these steps is fairly large and different conceptually, we'll focus on just the device context base address array today and focus on the command ring in the next video. Now that we've got the outline and the plan for what we need to do to set up the operational registers, let's talk about what DCBAA actually is and how to go about implementing it. The device context base address array is nothing more than just that, a block of memory treated as an array where each element is an 8-byte or a 64-bit integer value representing a physical address. Whenever a new connection is established with a USB device, in order to set it up, you would have to allocate a data structure called a device context. You don't need to know the details of the device context structure yet, but just know that it is used when setting up communication with connected devices, and is a place for the xHCI controller to store various hardware information about the device. When you allocate a device context, you would take its physical base address and store it in one of the slots of the device context base address array, or DCBAA. And as your pool of connected devices grows, the DCBAA will start getting populated with more and more addresses. Now you may notice that we started populating the table with the addresses starting at slot 1 and not slot 0. This is done because slot 0 is special and is a reserved slot, and it is reserved for what's called a scratchpad array. Even though QEMU usually doesn't do this, on real hardware, xHCI controllers oftentimes require pre-allocated pages of memory to use as scratchpads for various controller operations. What you as a driver developer are required to do is allocate the necessary number of these pages for the controller to use and set up an array where each element is simply a physical address pointing to one of these pages. When we first parse the capability registers, we save the value called the max scratchpad buffers, and that's exactly the number of scratchpad pages required by the given xHCI controller. If the number of required scratchpad buffers is at least 1, we would set up the scratchpad array and store its physical base address in slot 0 of DCBAA. Finally, when the device context base address array is fully allocated and set up, we would need to take its physical base address and assign it to the DCBAA pointer register in the operational register set. I feel like what scared me the most about this when first starting out is that I thought that all these different device context slots would have to be allocated and initialized when initially setting up the DCBAA for the first time. But in reality, most of the memory is literally just zeroed out, and it will only get populated one at a time when setting up connected USB devices. Now that we know what the DCBAA data structure looks like, Let's jump back into the code and start implementing this. Alright, so the first thing we're going to do is create a couple class member variables here. The first one is for the actual DCBAA, and another is going to be essentially a copy of device context address array, but for storing virtual addresses of device contexts. As you remember, DCBAA contains physical addresses because they're provided for xHCI controllers' use. So just for personal convenience, for our drivers' use only, we'll keep a copy of DCBAA, but for virtual addresses. We're going to need them later on when working with device contexts in later parts and setting up USB connections. Let's now create a function called setupDCBAA, and let's create a definition in our CPP file now. And then we're going to call it in the configure operational registers function above. Alright, great. Let's start implementing it now. First, we got to figure out the size in bytes for our DCBAA structure. And that will be the size of a uint pointer, so 8 bytes, times our max device slots. And it's a good idea to also add a little bit of padding afterwards, so we'll do max device slots plus 1. As a next step, we got to actually allocate the memory for our DCBAA. And for that, we'll use our allocate xHCI memory function. And since the return value of it is a void pointer, we have to cast it to a uint64 pointer. So let's call it and pass in our calculated size as a parameter, along with the appropriate alignment and boundary constants. Now, let's also not forget about our virtual address copy and allocate the memory for that as well. Since only our driver will be using it, there is no strict memory alignment requirements for it, so I'll just use my kernel's heap allocator for this. Alright, wonderful. I'm now going to paste this little documentation snippet from the official xHCI spec that reminds us of the setup for the scratchpad array. So it says that you can retrieve the max scratchpad buffers field from the HCS params2, which is a field in the capability register set. And luckily, we have already done that in the first episode, right here. So let's check if that value is greater than 0, and if so, we'll implement creating the scratchpad array here in a second. But before going into more memory allocations, as a final step of this function, we're going to have to take the physical address of our allocated DCBAA structure and assign it to the DCBAA pointer register in the operational register set. That's how we're going to get the controller to actually recognize it and use it later. So at this point, if you're only working with QEMU and don't care about real hardware, from my experience it never requires scratchpad pages, but it's never a good idea to rely on that. Plus, we also do very much care about running this on real hardware later. Alright, so let's go into our if block here. And the first thing we're going to do is, similarly to DCBAA, we will allocate the memory for a scratchpad array that will store addresses for scratchpad buffers or scratchpad pages. For the size of the allocation, we will use max scratchpad buffers value multiplied by the size of an address, so a uint64, the same as we did for DCBAA. Now that we have the valid array, we can now loop through and create these scratchpad pages, and populate the scratchpad array with their addresses. And just to remind you guys, the size of each scratchpad buffer is a regular 4K page. After allocating the page, we'll get its physical address and store it in the scratchpad array. Finally, we will get the physical address of the scratchpad array and store it in the first slot of the DCBAA. Additionally, we'll mirror it and store the virtual address of the scratchpad array in our virtual DCBAA copy. And that's it! We've now successfully set up the device context-based address array structure and are now one step closer to having a fully configured operational register set. Let's now compile and run the project to see that the DCBAA got allocated successfully and that the operational registers reflect that. And there you go. As you can see, our device notification control register is now configured, and the device context base address array pointer register contains a valid physical address to our DCBAA structure. And the config field has the same value as the max device slots and capability register set. And that is it for today. We are one step closer to being able to start the controller back up and start properly communicating with it. In the next episode, we're going to talk about various types of rings and focus on setting up the command ring, which will allow us to send commands to the xHCI controller once it is started again. Thank you all for watching, and see you in the next part.